Material with optical density value high bends the light more than material with optical density value low. Okay, our first impression is we might not understand what this statement is all about. But let's compare glass and water. Okay, so glass is here, and I have air and glass here. I'll just use a green pen to indicate this part. Okay, look at this part first. From air to glass, the light goes from air to glass. Let's look at the diagram. From air to glass, this one, red arrow, air to glass, angle A and angle B. Okay. Then you have water, meaning air, the one I circle, to water. The light bends towards normal comparatively less. What does this really mean? Let's compare two charts. These two charts is more or less the same because it comes from air. This one also comes from air. So it has a certain angle of A here and a certain angle of A here. So it's basically the same light ray. But this same light ray, when they go into or penetrate into glass, and this one penetrate into water, it actually have different characteristics of bending. Okay, so this is the dotted blue line is a line that could have been, and it tends to bend more. Okay, I wrote here bends more towards here, so it has a angle B. So this angle B compared with angle C. Here air to water, so this is a line that could have been, and you realize that the bending is actually less. So bending less, you have this angle C tend to be bigger. So we have this situation. And why do we have this situation? We have this situation because the optical density of the glass is higher. Optical density higher will tend to bend the light more. Okay? Material with optical density value high will bend the light more towards the normal. More towards the normal. Okay? So you can say more optical density or higher value of refractive index, the R will be smaller because it bends more, so the B becomes smaller. Okay.